Hello students, we will continue our study of high-tech architecture and we will look at the second presentation on the basic rules that govern the aesthetic of high-tech buildings. There have been major changes that have come in the high-tech buildings. So what the buildings as they began in the 1970s and what they are today, there is a major shift. The basic way in which to explain it is more to do with substance today than with style that was there at the beginning. Today's buildings are high-tech in terms of the way that they are smart, energy efficient, sustainable, climate responsive, lots of things that technologically make them smarter. That has been one very big contribution of high-tech architecture to modern architecture or contemporary architecture today, that buildings have truly become high-tech when it comes to technology. Coming back to the basic rules, we have already seen inside out, celebration of the process, transparency, layering and movement. Today we will see other three, which is bright flat coloring, lightweight filigree of tensile members or lightweight network of tensile members, and optimistic confidence in a scientific culture. We had already seen this bovilism, inside out style, for example in the Pompidou, where the design principle was to maximize the interior space needed for people in exhibitions, and the strategy was to keep all the structure and services on the outside. So the structures and services are on the outside and the space is completely free for people and exhibitions on the inside. The next we had seen was celebrating the process. We had seen the Aachen Medical Facility or the HSBC or Lloyds, where their intent is to show us how buildings are made and how they work. Therefore, the structure and services are exposed and visible to us. The third rule that we had seen was transparency, layering and movement, transparency in terms of the extensive use of glass, so that even in a building like the 88 Wood Street, which encased the services and structure, they were still visible through the glass. Layering is, for example, if you see any of these buildings like Pompidou, there is a layering of the structure, then the services, then comes the main exhibition area. So there is a sequence in which the spaces have been arranged. There is a layering of different spaces or different components of the building. Movement refers to how they used to make their staircases, elevators, escalators visible for everybody to see. For example, again in Pompidou, the elevator to or the escalator to take the people up through the building is via a glass tube on the outside. Here also in 88 Wood Street you see, though the glass is there, but the moving, the transportation parts of the building, the staircases, elevators, etc. are visible on the outside. Now we come to bright flat coloring. We see that in Pompidou and in Moss, where there are bright colors as engineers do, to distinguish between different kinds of structures and services and the ease of understanding and usage. This led to the comparison of this kind of colors used in these buildings with color coding used in oil rigs and engine rooms of ships, as you see for example here, or the colors we see in engineering, whether in an oil tanker or in the engine room of a ship or in an oil rig. This kind of color coding is done. And engineers have color coding, for example the color coding to mark underground utility lines. An extensive set of colors is there for that purpose. Again, bright flat coloring is used in a large number of products, or it began to be used. Color, besides color as a functional necessity, it also became an associational component. We find colors in clothing and consumer goods and consumer electronics and sports cars. All of this was a break from the past, and thus we find that this color even in building like Pompidou, in which the air conditioning ducts are blue, the plumbing and water pipes are green, the electrical systems are yellow, the circulation, that is the elevators, escalators, etc. are red, and the water tanks and structural frame is in white. And thus they have used color similar to engineers, the way they would code the building, code their machinery with colors. They have coded the building with colors so that you can easily read which component it stands for what? We know when we see blue that it is a part of the air conditioning system, or when we see white it is a part of the water tanks or the structural frame. We see green and we know it is a part of the plumbing in the water pipes. Now, why need it? Why do we need color? Obviously because of the aesthetic reason of it. With all these services on the outside, by giving this kind of color palette to it, they made it very interesting. But also for clarity. Each service has its own color, therefore people can actually read the building, and Pompidou pioneered this. It's also created excitement, like we find colors in sports cars or machineries. Same kind of excitement came in the building also. Now in this case, the white ducts, because I had mentioned here the white ducts are for water tanks and structural frame, but in this one case these massive white ducts are actually ventilation shafts of Pompidou for underground areas as per the assigned color coding, but this is diverging from that. Rather, this should be included in the white coding, the ventilation shafts. Now the blue truss we see on the inside of Pompidou, and then we have bright flat coloring, for example in the Inmos factory by Richard Rogers. We see bright Renault yellow in the Renault Distribution Centre, again by Norman Foster, and in this there were Renault yellow columns. The Renault yellow was actually the corporate color of the Renault car company and long been used in its branding. So instead here structurally, instead of having a base, a shaft, a capital, what we have is a mast which has got a joist or these curved beams, and it's got these tie rods which is holding the beam. So this entire structural system of a mast with joists and these cables, which is all completely well articulated at the center, has replaced the base, shaft and capital. Now we find in 88 Wood Street that there are these exposed ventilation funnels of bright colors. They are for air intake and exhaust shafts which channel fresh air into the building's underground mechanical system, but they also play a role in the aesthetic on the street level. The high-tech street aesthetic is the role that they are playing, and these primary colors Rogers has used here is similar to what he did in Pompidou with piano. Inside the building also in 88 Wood Street there is color, and then bright flat coloring. Why it is needed in the 21st century? Many buildings have it. This is both brand and technology appeal. The color is as identity, the color is as machine aesthetic, having an industrial feel, like in the Reina Sofia Museum extension by Jean Nouvel. He used bold red flat panels to mark the circulation in the building. Then we have this amazing color gradation that is happening in the Barajas airport by Richard Rogers. Here these are steel trees or columns with bright flat colors. They grade from yellow to blue to green in order to guide orientation in the airport. Thus it becomes a way-finding mechanism. Also it lends aesthetic to the building and a sense of joy or calmness to the passengers. Then in Snedd, in Cardiff, the Welsh Parliament, the bright flat colors actually restrained. As you see in these pictures, you will not be able to directly see the colors. There is flat tonal contrast in glass, steel and timber finishes, and very restrained use of such concept is used here. But as time passed, Richard Rogers and Norman Foster turned towards the silver aesthetic. Particularly after Pompidou, Rogers and Foster also simplified the color coding. They brought in silver aesthetic with these integrated ducts and structure within a palette of grey. That is what we find in both these buildings. It is not that the Rogers didn't go back to color. Of course, he went back to color in many of his buildings, but there was this silver aesthetic part also. An attempt by high-tech architects to fit their buildings in a more conventional context. For example, silver or grey aesthetic is there in our consumer goods, in our refrigerators or laptops, tablets or washing machines, dishwashers or phones. We find the silver or grey aesthetic. So in 88 Wood Street, what I have shown you the colors, but actually those colors are very restrained within a silver or grey palette of the 88 Wood Street building. So moving on from Pompidou, Rogers used the silver grey aesthetic with a very controlled use of bright colors in this building. So this silver and grey aesthetic you find in 88 Wood Street, you can compare it with the Pompidou, both buildings done by Richard Rogers. Then we come to the lightweight network of tensile members or filigree of tensile members. A network of thin stretched structural elements like cables, rods or wires, almost like a lace or a net. This thin steel cross bracing we find here again, for example in the 88 Wood Street, we find it in the Pompidou, and the tent shaped tensile membrane held by cables we find in the work of Fray Otto in the Munich Olympic Stadium 1972. This building is what we look at when we talk about lightweight filigree of tensile members, the Schlumberger Research Centre by Michael Hopkins in 1985. Before that, just to give you once again a recollection of the Renault Centre, a lightweight filigree of tensile members, the Renault Distribution Centre by Norman Foster in 1982. In this, it is a very highly flexible and adaptive building which contains the warehouse, training school, restaurant, showroom of the Renault Research Distribution Centre, and it has got a yellow exoskeleton which is the memorable image of Renault, and they used it for many years as a backdrop of their UK advertising campaign. Now it is based on the kit of parts or the toy which I had shown you earlier, the Meccano. The Meccano actually comes in a set of a kit of parts and you put them together to make a machine or any kind of element, and here the same concept is used, a system which has got reusable metal strips, plates, wheels, axles and gears and plastic parts which can be connected using nuts and bolts. The building's working model and mechanical devices, they come from this kit of parts. So here, now coming back to the Renault, it is a 25,000 square meter building with these 59 of these bright yellow mast and arched steel beams, and the whole structure mass is broken into this very decorative work in Renault yellow, a filigree of tensile members in which you have the mast, you have the joist and you have the cables that are holding the membrane, that are holding the joist. Now the elongated hall, there are 42 identical square modules of 24 by 24 meter, and each module has a PVC membrane roof across these stretched across the arched steel beams, and these are held by the rods. The rods are connected to the masts and they transfer then the load to the ground. Each mast is 16 meter high in Renault yellow. The functional areas, a total of 10,000 square meters, are all united under this one single roof created from these 42 identical square modules, and the building is, because of the way it is done modularly, it can be extended continuously as much as wanted. Now because of the modular structure, this is large flexible open space for industrial warehouse racking and storage, and the spaces can be configured as needed throughout the lifespan of the building. Coming to the Schlumberger Centre, it is again showing this lightweight network of tensile members, such structures that imply endless extension, openness to change, flexibility and free movement. There is a certain sense of dynamism about it. The same we saw in the Renault Distribution Centre. The only difficulty, there seems to be some ambiguity about these structures with regard to the clearly defined space or the positive space. So Hopkins' first major building was this building, which is a milestone in British high-tech architecture. It is centered around the drilling rig test station. It is a rare combination of a research facility and having industrial function within one building of oil exploration and drilling technology, and I will show you that. The steel and timber space frame trusses, these are steel and timber space frame trusses that are supported by these masts. the masts have tie rods which are holding to this PTFE or membrane or the Teflon coated fiberglass membrane. So the entire structural system is the space frame truss held by the mast, and from the mast the tie rods go down holding the Teflon membrane. So the central span is 27 meters width. The Teflon coated fiberglass fabric is here, which transmits about 13% daylight. The cables transmit the weight of the fabric to the ground via this suspension bridge kind of arrangement. The mast and the trusses, they create this suspension bridge kind of arrangement from which the tie rods are able to transfer the load to the ground, and thus this is how the structure of the building is, and therefore as a result of this structure the entire space within it is completely column free. So under this fabric roof, two things are made possible. Because of the height achieved, we can have the drilling station, test station within the, because there is ample height, and the ample height also provides for a very tall winter garden, very large space. So for the workshop or the drilling station we need height for drilling. For the winter garden also we need height in order to have light and shape and give character. It seems like an outdoor space, though it is completely protected from the weather. So this is how the section looks like, and this is where the drilling facility is. Besides the main spaces, there are smaller spaces also, and there are monitoring and planning rooms which look into the workshop. There are these smaller private offices on the outside of the building on either side, and they look towards the landscape. This is the interior of the Schlumberger Research Centre, and the circulation and meeting spaces are designed so that they all come together with all the other spaces, so that the scientists and the researchers are able to have informal interaction throughout the building. This particular building showed how industrial high-tech aesthetic could be adapted for a corporate research workplace. Then comes to one of the most famous buildings at the turn of the century, the Millennium Dome, which is today called the O2 Arena in London by Richard Rogers. It was a centerpiece of the Millennium 2000 celebrations held in London, and this particular vast domical structure has a circumference of 1 kilometer, a mast that rises to 100-meter height. Its overall domical height is 50 meters, and it's a translucent structure made of PTFE glass fiber membrane. Now I have shown you some of these slides earlier. I am just trying to collate them together and to help you remember that those pictures again. There is an open flexible space which can house a variety of events. Now the entire concept of the serviced zone omniplatz has been used by Rogers even in this building, which I will show you. Here it is precisely situated on the meridian line, and there is a symbolism in the structure. Each of these 12 yellow masts symbolize 12 hours on the clock, 12 months of the year, 12 constellations of the zodiac. The cables that support the structure from these towers represent the lines of time, like the spokes of a clock, and how it is holding the world together. The circular plan, again there is symbolism in structure. The plan was circular to indicate wholeness and unity globally. The translucent fabric roof is for lightness and openness instead of a very heavy commemorative memorable architecture that could have been made instead of this. A very lightweight structure was made in memory of this very important moment. A temporary tent for the nations which is democratic and accessible, not a closed off monumental landmark. This aspect of democratic accessibility will come back repeatedly in some other buildings that I will show you. So though it is not actually a dome, it is not self-supporting, it is a dome shaped cable network supported by these series of 12 masts. The canopy is made of PTFE coated fiberglass fabric or Teflon. It's durable and water resistant. We have seen it in a couple of other buildings also. And there is a lightness in the structure, so much so that when the entire enclosure is made, the entire roof structure weighs less than the air that is contained within the building. The masts are illuminated at night and they are both functional, symbolic and aesthetic. Each mast has a four-legged quadrupod base, and the ventilation pods, this blue cylinder, is placed on the outside of the dome. The service ducts from the pod go into the base of the dome, and from there fresh air is distributed and stale air is extracted. Thus the mast and the pods, the structural system and the services are a part of Rogers' high-tech strategy of placing both the structure and the services on the outside of the building. Thus the interior again becomes a very vast, uncluttered service space, again becomes an omniplatz. Both the mast and the pods are illuminated at night and become a part of the aesthetic of the building. Just as in other high-tech buildings where the services and structure placed outside just is not functional, they also have an aesthetic role, so also here in this building. The pod has got this louvered cladding that you see in order to conceal the equipment, the airflow, which allows airflow while concealing the equipment that is holding. It is also remarkably inexpensive. It cost a total of 43 million pounds, the Millennium Dome, as against 758 million pounds for the entire Millennium Experience project. The two pictures that you see here is how the space is being used today as the O2 arena. Last of all, we come to the point of the optimistic confidence in a scientific culture that the high-tech architects propounded. The high-tech architecture celebrated machine age, science, technological progress as positive forces, and the buildings had their engineering, services and structural systems on the outside as a proud display of technology. If we have the technology, why should we not celebrate it, is what they used to say. It was not done cynically, but they had an optimism that if we project this technology and science, we will improve life in society and the environment. So, how it shows in buildings, if we want to recap it, in Centre Pompidou, exposed pipes, escalators, ducts, technology as a cultural spectacle. In the Lloyds of London, inside out building with a confidence in engineering. In the Inmost factory, a delicate tensile roof, prefabricated kit of parts. In the HSBC Hong Kong, it's got a suspension structure with modular floors and an open public atrium or plaza, an open plaza at the ground level. All these embody their faith in technological progress expressed visually in these buildings. If you take the example just of Richard Rogers, how consistent he was in using his high-tech concepts in his works. If we look at Pompidou 77, Lloyds 1986, Inmost 1982, PA Technology Centre 1983, 88 Foot Street 2001, Lloyds Registry of Shipping 2000, Leaden Hall Building 2014, Millennium Dome 1999, all of them have inside out with structure and services on the outside. All of them have a flexible interior, a fully serviced zone which is called the omniplatz. So, though the buildings varied dramatically from a cultural center to an office building to a factory building to a Millennium Dome, in all of them, he consistently followed this concept of putting together the building. But there has been criticism about this. Why? They say, like you see here in this model of the Lloyds of London, which in fact you can never really see the building in its totality because of the surrounding urban scape, but in the model we are able to see it. The rules of composition are quite primitive, jumbled, especially at the top and bottom of the building. It lacks classical compositional hierarchy. The base, middle, top, rhythm, proportion does not seem to be there. There is a futurist promise in the attitude towards materials, colors and invention, but this interior space is often undefined. It is a huge service shed without a human scale. It is chaotic external massing with multiple parts which are bolted on without a clear compositional hierarchy. This is what the critics have said. But let me just show you one picture or rather two pictures that tell us something different. Look at this picture of Pompendo, but it does not look chaotic. Even when the structure and services are on the outside and they have been bright color coded, you see the elevation has a certain rhythm about it, the way the entire elevation has been arranged. And when you see the Lloyds of London, there is a regularity in the facade, a basic principle used for international style as defined by Henry Russell Hitchcock and Philip Johnson. So it is not so easy for us to say that there is chaotic massing. There are aspects to the building when we look at it overall, yes, there is a certain sense of chaos, but there are other aspects to it where you do find rhythm and certain symmetry in the way the services have been arranged. Criticism that many ideas tried together at the same time with emphasis on teamwork and simultaneous creation of separate parts of the building leads to sub-assemblies which tend to dominate the building, and this criticism appears to have some measure of truth. When you look at the Lloyds of London again, you find as if the sub-assemblies are dominating the building. Therefore, it is said that it's the right style for stadia, sports halls, airports, factories and large multi-purpose centers, but it's not appropriate, for example, in offices, housing, schools and traditional building types. There is a conflict arises in those types of buildings. We will come to an Institut du Monde in Paris. In this Jean Nouvel, I will quickly go through as we are running out of time. Other functions devoted to Arab culture relation with France are shown in this building. It is a building high tech, not in style but in its use of technology. It is a minimal composition of forms in which this part of the building which you see here which is towards the river Seine gently curves like this, and there is a sharp deep cleft created here, and here it meets this rectilinear block in front of which there is a large plaza. The north facade of the building is this part which is facing towards the river Seine. It has got a polished look, reflects the skyline of the river embankment, and it has got this continuous aluminium frame which is dividing the facade. The south facade is the more interesting one. It has got these 240 square grids on it, light sensitive metallic apertures like camera shutters that open and close to regulate light coming inside the building. The apertures are controlled by photoelectric cells, which is this thus shows early building automation, an early example of a kinetic facade, a facade that is not passive but it is active. This is a technological reinterpretation of the mishrabia screens used in Arab Islamic architecture. We see the mishrabia in Arab Islamic architecture which was used for the privacy of the women who could sit inside and look outside while having a certain sense of air and light and view. So these panels are of the Institute Arab du Monde have been built on this principle. So we compare the mishrabia with the institute, the Arab Institute. Now these 30,000 light sensitive diaphragms operate like camera lens controlling the penetration of the sun inside the building. Unique use of high tech photosensitive devices to control light levels within a building, an interest in smart materials which respond to changing environments in the buildings. But the only unfortunate part is, the problem is that this system is no longer working. This is where the optimistic confidence in a scientific culture, there is a question mark against it. So up to now what I told you shows the positive aspect or the optimistic aspect of their hope in the scientific culture, but the final result shows us that sometimes such technologies do tend to fail. Still, in spite of this, the south facade of the Arab Institute continues to remain beautiful. In conclusion, high-tech architecture is a milestone of late modernism. It's a style of optimism, invention. Its legacy lives on not in exposed pipes and ducts, but in today's eco-tech and smart tech buildings, where technology is embedded in the building rather than displayed. For example, this building called The Edge. We'll continue on from here in our next presentation on buildings which are places to work under high-tech architecture. Thank you.